Hi everybody, it's Mr. C. I thought I would do and cover the notes for section 6.7. We are graphing linear inequalities. Now I know that we're skipping ahead a little bit, but that's okay. Now that we've solved inequalities, we want to be able to graph them. And just like when we were solving them, it's very similar to when we have equations. So we'll just jump right in. You'll see how it works. There are a few extra details that you'll want to keep track of as we go through. So, all right. So the first part here, it's asking you to tell whether the ordered pair is a solution of the inequality. So we have our x and our y values that we need to plug into our inequality and see if it actually makes a statement that's true. If it's true, we're good. It's a solution. If it's not true, then that means it just doesn't work. It doesn't fit with the inequality. So here we go. We're going to do 4 times, instead of x, we're going to use a -2. Subtract 7 times 4, and that's going to be greater than 28. And now I'll just have to evaluate this. So 4 times a -2 is a -8. -7 times 4 is a -28. So it's a -8 minus 28 is greater than 28. Well, now I do a -8 and I subtract 28 more. I get a -36 is greater than 28. There's really no reason for me to think that this is a true statement. This is absolutely not true. So it's not a solution because it's not true. Okay, I'm hoping that this is making sense. Now we're going to move on to the other side. Let's try this ordered pair. We've got our x and our y value here. We get 3/4 times -8, and then we'll subtract 1/3 times 12. And when I do the math here, oops, actually I got to make sure that it's less than 6. So now when I do the math, 3/4 of -8 is going to be a -6. Now I could go over here to the side and do them and work this out, which you can on your own. -8 over 1, cancel these out, so that's a -2, and that's 1, and I end up with -6 over 1. Okay. So I get a -6, and then over here, basically 1/3 of 12 is 4. And I keep that negative sign there. So I got a -6 minus 4 is going to be less than 6. When I combine these, -6 minus 4, that makes a -10. Is that less than -6? Well, yes, of course it is. So I say, yes, that's true. So yes, it is a solution. So far, it's not that hard, right? We're solving it just like we would our regular equation. But in this slide, we want to make sure and provide the information you need. You know, you'll want to go back to this maybe at another time, but there's a few details here, okay? First of all, there is a boundary line that's created by an inequality, and it's just like when you graph an equation, but there are a few things that you have to include. You use a dashed line if it's less than or greater than, but you use a solid line if there's it's a possibility that it's equal. So it will look different depending on which of these two symbols you use. After that, you have to test the point, okay? You have to make a decision which side of the boundary line is the good side, the side that has all of the solutions. Once you figure that out, you shade, or what I like to say, you highlight those in order to bring to light or make sure and highlight for other people what are all of the solutions. Okay, if it's not shaded, then it's not a solution. Okay, so let's look and see if we can make this happen. Here we have 2y minus 4x is greater than negative 10. If I were going to solve this, this is what I would do. I would go, I'm going to add an extra slide here. 2y minus 4x is greater than negative 10. 2y minus 4x is greater than negative 10. I'm going to take, and I'm just going to, I'm going to put this in slope-intercept form to make it easier for me to graph. So that means I'm going to add 4x on both sides. I'll get 2y is greater than 4x minus 10. Then I will divide by 2 on both sides. So my real inequality is y is greater than 2x minus 5. I go back and check, did I divide or multiply times a negative number? No. So I'm going to take this inequality and I'm going to go back to my my graph over here. I'm going to write this in there. Y is greater than 2x minus 5. Now that's correct, isn't it? I can double check. Yep, 2x minus 5. Y is greater than that. Okay. Normally, if this was y equals 2x minus 5, I would use this as my slope and this is my y-intercept, which is exactly what I'm going to do now. I'll take negative 5 as my y-intercept, and then I'm going to rise 2 and run 1. Rise 2 and run 1. Rise 2 and run 1. After that, I will connect it. And this is where I'm going to pause for a second because you remember it said if it's one of these symbols, a greater than or less than symbol, I need to use a dashed line. Oh, well, okay. I'm going to get rid of this old line that I used. Okay, I'm actually going to just cut that out. Okay. So instead, when I go to draw my line, let's use a dash line. So I got a dot, 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 dot. It's not perfect, but it'll work. So line going this way, line going this way. What we have here is a boundary. Okay. It's separating the coordinate plane into two separate fields. One of the fields has all of the possible solutions for x and y, but I don't know which one it is. So I'm going to use the origin as a test for me. Okay, that's 0, 0. So I'm going to go back over to my slide here. Y is greater than 2x minus 5. And I'm going to plug in 0 for this. Does this make the statement true? 0 is greater than 2 times 0 minus 5. When it's all said and done, this cancels out. So now it says 0 is greater than negative 5. Is this true? Yes, it's true. What does that mean for me? Well, when I look back at my graph, I found a point on the, we'll just call this the north side of my boundary line. And since this one is true, that means everything on this side is true. So I'll get out my highlighter, which is nice for me to use here. And I will go right up into the boundary and I will highlight all of this here. You would just kind of shade it in lightly with your pencil or something. But all of that highlighted area is where I can find points for x and y that will be a solution. If I pick out another point, like say, let's say like -1, -1, and I put that into my equation, it's going to make a true statement. However, if I try and use a point like this, like 4, -2, guess what? When I plug it into my inequality, it won't be true. So it'll be false. I hope this is making sense. So now we'll try this again on the other side. We'll rewrite this one. I'm going to go back. I'm going to add in another one. It's 3 times x minus y is greater than or equal to 12. So 3 times x minus y is greater than or equal to 12. Now I use the distributive property here to make 3x minus 3y is greater than or equal to 12. I reorganize to get y by itself. So I subtract 3x This cancels out. Now I have a negative 3y is greater than or equal to a negative 3x plus 12. Keep going. I know it's a little bit of work here, but it's going to help me in the end. I'm going to get this cleared up. I divide by negative 3 on both sides. Now keep in mind, once I do that, I immediately have to switch that symbol around. So now y is less than or equal to x minus 4. I'll go back to my original problem. Y is less than or equal to x minus 4. I go to my graph, switch colors here. I'm going to find my y-intercept of negative 4, and I'm going to follow my slope of 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. And I'll make my line. Now, since it's a greater than or a less than or equal to symbol, like I have here, I will use a solid line. All that means is it's just like the open circle and the closed circle when you're graphing on a number line. That means this line will include these points on the line as part of the solution. So once again, I have to test it. Are all of the solutions above the line or below the line? I'll go back, and this time I'll use my equation y, or my inequality, y is less than or equal to x minus 4, and I will plug in 0, 0. 0 now is going to be less than or equal to 0 minus 4, which means this. This is the result. Is 0 less than or equal to negative 4? No, it's not. So what does that mean for us? I go back and I say, this origin right here, it's not a part of the solution. So what does that mean? That means the other side is the side that I will highlight. If I get my highlighter out, get that going, and I fell down. Hopefully now it's starting to make a little bit more sense. This is something you cannot rush. Oops, let's change that. Can't write with my highlighter. Do not rush. You have to go step by step. So take your time. It might take you a little while, but that's okay. As I continue, I'll skip past some of my new slides here. These are actually going to help us out. Then we're going to move a little faster through these because if x is less than or equal to 10, that means x is always 10. And that just means I have a vertical line, okay, going through 10. And since it's has an equal to sign with it, that means I have a solid line going like this. And it's super simple. What are all of the numbers that are less than or equal to 10? I'll highlight those. Maybe with green this time. What are all the numbers that are less than or equal to 10? Well, it's all the stuff over here. Oops, that didn't work very good. Let's try a different highlighter. The big one. There we go. All of these right here. Everything on this side of the graph is going to be a possible solution because all of the values for x on this side are less than or equal to. On the other side, let's try a different color. I've got y is greater than negative 2, so I'm going to go down to negative 2. All of my y's are going to be negative 2, so it's going to make this nice line like this. Oops, what did I just do? I gotta change the quality of my line. This is just a regular greater than symbol. So instead of using a solid line, I have to use the dotted line or the dash line. So right through here like this, I put an arrow on either side. What are all the numbers that are greater than negative 2? Well, it's all the ones that are above, right? So I fill that in. Again, you'll just use your pencil. Just use the side of your pencil, make it nice and light, and it should be fine. You don't have to darken it in really dark. That's not what we're looking for. If I keep going, here we're going to work our way backwards. I have to find, and I think I'm going to scroll down a little bit here so that we can use more of the bottom area. grab my pen. I need to find my y-intercept and my slope. So I can tell pretty quickly that this is going to be the rise over the run is going to be 1/2. So 1/2 x, and then the y-intercept is a -2. So there you have it. Now, I can't keep this as an equal sign, though. I'm going to have to rewrite that so it's a greater than, less than, or equal to. Since we have a solid line, that's something to notice. That means I need to have that equal to along with my inequality symbol. But I have to figure out what's going on here. I'm going to plug in 0 for this, okay? And I'm actually going to pick one, okay? So let's look. I'm going to pick that this, I'm going to like make a guess. I know that sounds weird, but let's just pick one and we'll get to see right away if it works. Is 0, I plug in 0, 0 for my x and for my y. Is 0 less than or equal to 1/2 times 0 minus 2? The result is 0 is less than or equal to -2. Is this true? No, it's not true. Well, guess what? In the picture, it's not true. So have I found the correct inequality? Yes, I have. So the 0, 0 is not supposed to be a solution here. It's shaded down below. So it looks like I've picked the right one. And I will circle this one. Y is less than or equal to 1/2 x minus 2. That's how it works, folks. You have to do a little bit more thinking for these. So keep that in mind. Step by step, take it slow. For my next problem, we got to do y equals mx plus b. I see that this is crossing at, what is it, 6, and then 4, and then 2, and then 0. So this looks like it's crossing at a +1. I also see that to go from one point to the next, I'm at 1, and I go up to 4. So that's +3, and I go backwards to 4. That's -4. So I've got a -3/4 x plus 1. That's my equation. You might be a little faster at that. You might not. You might take a little bit more time with that, but that's what I have. The next thing that I know is, since I see the dotted line, that means there's no equal to. So I'm going to guess y is going to be less than -3/4 x plus 1 if, let's see if this is true, 0, 0. Let's put in 0, 0. Y is less than -3/4 times 0 plus 1. Is 0 less than 1? Yes, it is. But in my graph, it's supposed to be a no, right? So since these don't match up, I'm going to switch it. I actually will go back in. So here, I'm going to use my colors to highlight and make sure you can see this. I'm going to cross this out. That's not right. It's going to be y is greater than -3/4 x plus 1. So those two are pretty challenging. It takes time. You might say, oh, well, I just look at it real quick and I pick out an equation, it's fine. No, you have to make a decision which way the symbol is going. There are some shortcuts to that. But for right now, I want you to think your way through it, okay? That's a good way to avoid mistakes. It's thinking your way through it, and it will help you to really understand how this all works. All right. So now we've got another example here. I'm going to take you through this example, and you're going to have some homework to do. So this is the last one. To try and keep in shape, you swim or run at least 6 hours a week. Let X represent the amount of time you spend swimming in 1 week, and let Y represent the amount of time you spend running in 1 week. Write an inequality that describes the number of hours you exercise each week in terms of X and Y. graph the inequality, and give 3 possible combinations of hours that allow you to meet your goal. Look, guys, I'm going to put up the answer here in a second, but I am kind of thinking that you might need to use your intercepts on this one. Okay, so you should stop for a second, pause this, and try this out. See if you can figure it out on your own. Then unpause it, and I will show you the solution here shortly. Okay, so here we are, we're back. I just wanted to show you a few of the answers that I come up with here. When I went to graph it, for one, I'm using a solid line because everything on this line could also be a possible solution. The inequality is I'm going to combine the number of hours I swim and the hours that I run, and that's going to be greater than or equal to 6. And I highlighted above here because, of course, if I swam 5 hours and I ran 5 hours, that's going to be at least 6. That's 10 hours total. All of these points out here, running 7 and swimming 7, running 7 and swimming 1, all of those would meet my my requirements that I had set up. So as we go down, this is what the graph looks like, and then there's all kinds of combinations that would work. There's millions. So now the last slide here is just talking about what you're going to do for homework tonight. 2 through 8, the evens. That's where you're just finding out, is it a solution? Is the ordered pair a solution? And so you're going to do some quick algebra work there and just evaluating. And then a whole bunch of this is graphing. Okay, so you'll get a lot of practice with that and some word problems. So take care of that tonight. That's your homework. And on Friday, that's when this is due. Okay, so we'll see you with all of this stuff done on Friday. Hope everything goes well for you, and we'll see you then.